Good afternoon, everyone. Jeez, how did that come out? Good afternoon. I gotta stop drinking Starbucks.
And it's morning.
Yes, I mean yeah. That's what happens when you've been here forever. So good morning, everybody, and welcome to the 11 o'clock session. This is Eric Wolff from Tails. He's going to talk about devaluing cloud breaches while gaining safe harbor, and he's going to explain that a little bit to you. So if you can welcome Eric, thanks.
Thank you. Thanks. Hey, before I dive in, I just want to do a really quick poll. So raise your hand if you're using AWS, Azure, or Google Cloud Platform or plan to use it. Okay, all right. So you're in the right room because I'm going to tell you stories about what's going on in the cloud these days, and then I'm going to provide you some guidance. I'm a vendor, and so I actually have some solutions in this content. And the other thing is that it's a short session, so I'll be outside the room and I can answer questions that I couldn't answer live outside at about 11:30 or so. So I'll be talking about averting cloud data leaks. And one thing that you're going to learn in the next few minutes is that no one can stop the breaches. The story of what I'm going to tell you is that you can keep the data safe even in the midst of breaches. So you can avert the leak, and you can actually gain safe harbor from breach notifications if you can keep your data safe in the face of breaches. So let's talk about breaches for a second. So I'm starting with Amazon EBS. Because S3 is the darling of breaches, but this was a finding that came out just a few months ago at GrrCON. EBS has a public mode that makes VHDs visible to anybody on the internet. There are hundreds of thousands of EBS storage arrays that are visible to the world. This is a challenge. Meanwhile, in July, Paige Thompson was caught exfiltrating 30 gig of Capital One data representing 106 million customers. It was not a happy story for Cap One to tell to the public, but I have some things to say about Paige and that in a few moments. And rolling back the calendar to April of this year, hundreds of millions of Facebook user records exposed on AWS S3. And then finally, with the end of my breach stories, Dow Jones, the parent of the Wall Street Journal, is the latest company to yet again misconfigure AWS, in this case it was S3, and expose mission critical data to the public. So the question that we start to ask here is, why hasn't Amazon stopped the breaches? And I'll start with a headline from Newsweek. In the wake of the Cap One, Jason Murdoch reported, Amazon refuses blame for the Capital One breach, says its cloud services, themselves were not compromised in any way. So that's point one about whether Amazon can or will stop the breaches. Meanwhile, they are cognizant of the challenges that their users face, and they continue to add tools and the corresponding complexity to using and securing AWS, including just a few months ago, starting to scan public IP addresses for open S3s and open EBSs. Delivering the Access Advisor at the end of, let's see, sorry about that. Mac is not supposed to go to sleep during presentations. Offering what they refer to as their well-architected review for many, many, many years. Meanwhile, in the wake of the Cap One breach, Ron Wyden, senator from Oregon, sent a letter to AWS saying, what is going on here? Why does this keep happening? And these are just a few quick sentences from AWS's response to Ron Wyden, We will proactively scan the public IP space. We will redouble our efforts to help customers set the least permissive permissions. We will make our anomaly detection services more broadly accessible. We will look at additional additions to subsystems deeper in our stack. That was a code word for the challenges that came out in the wake of the Cap1 breach that said that the IAM subsystem that lives underneath every infrastructure as a service virtual machine has a lot of vulnerabilities in it, and AWS is aware of it, and their whole IAM, or infrastructure and access management systems, depend upon it, and it's full of vulnerabilities, and they're aware of it and they're fixing it, but when will they? But the question no longer goes to AWS. We assert that it's essentially impossible to stop breaches. Why? Because breaches are largely caused by human error resulting from either complexity or convenience. Complexity is dramatically grown when customers use multiple cloud service providers, because every cloud service provider security schema is slightly different. And you end up needing to get a certification for Azure and a certification for AWS and a certification for GCP. And can you keep all of those cloud security management schemas alive in your head all the time? Do you have enough people to assign one person to AWS, one person to Azure, and one for GCP? Probably not. And as the complexity grows, you just throw up your hands and say, I'm going to temporarily leave this bucket open for the public because it's the only way that my internal users actually can get to it, because I can't quite figure out the IAM relationship that I need to establish so that all my users can get to data shared by other people. Meanwhile, vulnerabilities, there's just going to be no end to vulnerabilities. The software industry is always moving forward. There's always new applications. There's always new services. There's always new companies. And you can't always patch the vulnerability as quickly as you want. And the two examples I have on the slide here was that the vulnerability that was believed to be at the root of the Cap1 breach in the mod security web application firewall was reported at Black Hat 4 years prior to its use by Paige Thompson. And then same month, Imperva, who is a security vendor just like I am, experienced a bug in their database security, and they had a compromise of their customer data in August. And then finally, insiders remain. There are two types of insiders. They're yourself as an insider, because if you're a sysadmin, you're an insider and you present risk to your data that I'll be talking about in a moment. But meanwhile, your admin privileges and vulnerabilities are the same in the cloud as they are on premises. So here's the example that I like to cite. We reported on a study several years ago where administrators revealed that, all things being equal, they used the same admin passwords for infrastructure as a service for their Linux machines on premises and their Linux machines in the cloud, which means that if an admin happens to be socially engineered, or the right phishing attack ends up on the admin's desk and the admin credential is given up, then that credential is given up in the cloud as well. And in the scary example of the Black Swan event, a Black Swan is a swan that may exist in public, but nobody's ever seen it before. Compromised AWS or Microsoft or Google employees are believed not to exist. And yet last August, we had a former AWS SE implicated, using her knowledge of AWS vulnerabilities to break into Cap 1. So the Black Swan event actually happened. And I'm not really making this up. In a recent survey by IDC, they revealed that 61% of data breach victims indicated that the attack was the result of a cloud infrastructure related vulnerability or misconfiguration. So the bottom line is that breaches happen for good reasons. Where none of us are perfect and the infrastructure that we use is imperfect. Meanwhile, these diagrams are taken from AWS and Azure's websites. They are known as those cloud providers' statements of the shared security model for cloud computing. And if you look closely at these diagrams, note that the blue section on the left and the blue section on the right is physically a lot bigger than the gold section or the gray section on the slides. What does this tell you? This tells you that you, the cloud consumer, essentially have significantly more responsibility for data security than the cloud provider themselves. Now, it's hard to read the tiny fonts in these diagrams, and you'll get these slides from the conference website, but you'll see that, for example, AWS specifically tells you that you have to manage the encryption that they provide. You have to manage all the data protection tools that they provide. And yeah, you can go to AWS reInvent year after year after year, and you can get your AWS security credentials. But then, as I said at the head of the hour, are you going to be able to remember the AWS subtlety versus the Azure subtlety in securing data? So what is a potential plan to protect your data? Well, you can end human error. I don't think we're gonna end human errors. You can assume that you or someone on your team or someone in the industry who's sitting next to you in this room right now will find a vulnerability before a hacker does. Or you can hope and pray that no admin will ever be socially engineered. To that, I say good luck. So here is a potentially better plan to secure your cloud data. Protect it with encryption, tokenization, and most importantly, encryption keys that you, not your cloud provider, control. If you consider this better plan, you may even gain safe harbor from having to disclose breaches of cloud data. So, you're going to leave this presentation and you're going to go back to your school or you'll go back to your team at headquarters, and one of the cloud sysadmins will say, but the cloud providers are giving me encryption and key management. And I'm here to tell you that cloud provider encryption is essentially equal to full disk encryption on premises. And the challenge with full disk encryption on premises and the challenge with full disk encryption in the cloud is that once a hacker has a key, all the data is in the clear. And essentially, FDE is simplistic. It lacks the protections that advanced encryption solutions provide. Now, I'm going to tell you a little story on this point before I move on. If you use full disk encryption on premises, what's happening is that whenever you read data from your FDE storage array, as soon as it leaves the disk, it's in the clear. Data arrives from SAN arrays and NAS arrays in clear text coming to the operating system. The reason why FDE works the way it does is that vendors are protecting data on disk from physical theft. And, this is an interesting story because I think it'd be pretty hard to penetrate an AWS data center and grab a disk out of an AWS storage array. I think it would be pretty hard. But the problem is that's not the problem. When the data is served in the clear to the operating system, then that administrative credential upon which the tower is built that has the risk of social engineering oriented breaches allows a compromised priv user to gain access to the data coming in from FDE or cloud provider encryption. Meanwhile, if you still have faith in cloud provider encryption, you have to note that access to cloud provider keys is tied to the cloud access policies. So rewind your brains to a few minutes ago when I talked about the IAM subsystem underneath AWS virtual machines. That infrastructure also controls access to the AWS KMS, that is the key management system, Key Vault. So there's some risk that leveraging any vulnerability in the underlying technology in AWS could result in an encryption key being gained. This eliminates the traditional defenses that you depend on, such as separation of duties and layers of defense. Another consideration, and this is absolutely self-serving because I provide solutions that mitigate this, but cloud provider encryption essentially locks your data in that cloud. I don't have time to go through it today, but in several discussions I've given in groups about this size, we learned in 2017, 2018, and this year about data repatriation. That is the notion of bringing a workload back from the cloud to premises. Repatriation is a very, very interesting consideration, but let's just go through the mental exercise if we can. So we lifted or shifted, or we did an engineered migration of sensitive data from our premises to the cloud to leverage the benefits of the cloud. And we encrypted it when we got there. Well, suddenly we need to repatriate some or maybe even all of the data that we encrypted up in the cloud. Well, unfortunately, we pay for the CPU cycles that our servers use to decrypt the data before I can bring it back down to my premises. And why do I have to decrypt it before I bring it back down to my premises? Because AWS does a very, very good job. They won't let you take any key from KMS down to your premises. They won't let you take it. So that means that you have to decrypt the data before you bring it down. And the same thing happens in a cloud-to-cloud migration. It's perfectly common, and everybody hears about stories where I had a data set in AWS, but I decided that certain aspects of security might be better in Azure, and so I'm going to move my data up to Azure. Oh no, have to decrypt all that data in Amazon before I drag it down in the clear to my premises before I can move it to Azure. So cloud provider encryption has that limitation. And then finally, I've harped on this already several times in the past 18 minutes. I've said that if you have to learn and maintain encryption in your multi-cloud environments across multiple clouds, you'll start tearing your hair out, even if you're just bringing your own keys to that cloud provider encryption. It's expensive to get trained, and it's expensive to maintain your knowledge of the security tools available from your cloud providers. And meanwhile, you really want to take a separation of duties perspective, just like the cloud provider told you to. The cloud provider told you that you are responsible for the security of your data. And I'm here to tell you that if you want to solve a whole bunch of problems, you can bring your own encryption by encrypting the files or tokenizing the data, and always, always control your keys. But I want to re-emphasize that I'm not here to tell you that the breaches are going to end. Human errors, vulnerabilities, insiders remain. And the challenge is that if you use cloud provider encryption and there is a breach, your data may well end up in the clear and is intrinsically valuable to the people who are trying to steal it. If the data is in the clear, the credit card numbers, social security numbers, addresses, names, and telephone numbers are all valuable to the hackers. If you can use an advanced encryption solution, when the breach happens, the data remains encrypted and has no intrinsic value to the hackers. So whether they know it or not, and whether they stop it or not, is immaterial, because once they have it, they can't use it and they can't leverage a dollar value from it. So we have products in the Vormetric data security platform that allow you to protect data on premises, in hybrid clouds, and in pure cloud environments, enabling you to react quickly to new data protection requirements and giving you single pane management of both encryption policies and keys that can travel from cloud to cloud. We offer data protection choices from the management of cloud provider keys all the way up to tokenization of data at the top of the compute stack, and bringing it all together with a single key management system can actually save you money over time. So we have this appliance, which is available in both physical and cloud-friendly virtual appliance form factors that provide centralized key management for encryption or tokenization across multiple clouds. This device, used at the center of a bring your own encryption strategy, enables you to move data from cloud to cloud without having to decrypt it prior to moving it. We have a product that we refer to as Vormetric transparent encryption that we claim can prevent privileged users or cloud administrators from gaining access to encrypted data. By operating in the operating system and providing encryption in the operating system, we leverage OS services to enable privileged users to do their jobs, gain access to file and volume metadata, but not gain access to the data inside of files and databases. And therefore, the compromised privileged user attack is averted. We provide data access logging such that you can gain early warning of an advanced persistent threat attack by recognizing in a SIM system repeated data reads, such as Paige Thompson's attack. And it's simple to deploy because it's wholly transparent to your work processes. Another choice is tokenization, where either format preserving or random tokens replace sensitive data in databases or in the cloud. You can tokenize data before going to the cloud. You can detokenize as needed in the cloud or not. You can statically mask data, and You can share safely statically masked data with third parties. And I've talked to a lot of people while I've been in Grand Rapids about people in the health community that are doing data sharing between clouds. The bottom line is you can protect PII and attain PCI DSS scope reduction and protect hackers from gaining access to your data. I'm going to skip this in the interest of time. You can bring these technologies to the cloud and you can manage them on premises, or you can take this centralized key management solution to the cloud. You can gain safe harbor. Safe harbor regulations are cited in many data protection regulations, including state data breach regulations and international data breach regulations. In the interest of time, I won't read to you the GDPR safe harbor, but you will receive these slides from the GrrCON website. And I sum up here. You can avert the dangers of cloud breaches by taking responsibility for your data, by dealing with the vulnerability that can't be predicted. The last line of defense is your encryption and keys that you control. And that's it. So I'm happy to take questions live now or outside the room at 11:30.